All right, let's start with the exercises. And this is the first exercise. Let's have a look and work this one out. All right, so the question says a point source is positioned at positions 5, and the origin is in the center of the field of view. So they want us now to create the resulting sinogram. So something that's good to remember is that sinograms are projections. And so we will be making several projections to make the resulting sinogram. And let's see. All right. So let's define a coordinate system. So right here we have an x coordinate system. Right here we have a y coordinate system. And over here we will make the resulting sinogram. So in this line we will have the angle. So the projections are made under an angle. And at the middle we will have somewhere here we have the r, the radius. I'll put it like this. Right. In here you do need to define which side of the center right here. So this is 0. Which side is positive and which side is negative. So in this case, this side here, let's say this side is the positive side, and let's say this side here is the negative side. Right here. All right, so let's have a look at it. So we have a point source at position 5, 5. So that is, let me see, 1, 2, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So that is right here. So for a point source. Alright, in this case, the initial or the starting angle is not given of the projections. So you can choose what you want to have as the starting position of the angle. In this case, we will choose this angle, but you can of course choose a different angle. So here, let's say make a line, a point source, and then this over here is our angle. This means that over here with our 0 degree, over here we have our 90 degree, over here we have our 180 degree, over here we have our what is it, 180 plus 90 is our let me see, is 270 degrees, and then all the way back we again have our 360 degrees. Usually make the sinograms from 0 to 180 degrees, but in this case we can go to 360 degrees to give a better explanation and understanding of what is actually happening with the projections while making the sinogram. So let's make here 360 degrees. Alright, so we have here 0, somewhere in the middle. I think that is around here. We have 180 degrees. Then here we have 90 degrees. And somewhere here we have 270 degrees. Alright. So for now, let's make our first projection, which is around the 0 angle. So let's grab a different color. We're going to make our projection. So right here is our projection. Let's make the projection. This is our projection, and it is at the angle of 0. So again, at the center of this detector, you again have a 0. And again here, you need to define which direction is positive and which direction is negative. So we will define this direction as positive and this direction as negative. And now we will look at the point source where the signal is coming from. So since these are parallel lines, a parallel collimator, so you have parallel lines. So you go here, you see parallel lines. So here on a detector you get a signal. Let me make this a different color. So here on a detector we get a signal. So this means that this is a distance r. And what is this distance r? This distance r is 5. But is it negative or is it positive 5? In this case, because we define this as a positive direction, this distance, this r, is positive 5. So plus 5. So now, if we're going to draw here in the sinogram, we can put a mark at 5. Let's say that this line right here is 5. They'll put a mark at 5. This distance is 5. Let's say over here we have minus 5. So right here we have a mark. So this is our first projection of our point source. Alright, let's now go make a detector at 90 degrees. So over here, detector at, detector at, that's better, at 90 degrees. Again, here you have the sender, 0. And let us see. So we have here, again, now you have to be very careful. So here, you get the signal here. But then now is the question, what is the distance? So this distance, we want to know this distance, because this is the r. This is what we would like to know, which is this distance right here, which we know is 5. But is it plus or is it minus 5? Well, we defined the direction of the detector for this to be positive and this to be negative. You see, it shifted a bit. This was the negative side and this was a positive side. As you can see here, it is a bit shifted, it's a bit rotated. And that's why you have to be very careful. So in this case, this 5 is a minus 5 of the radius. So in here, at 90 degrees, at minus 5, you put a mark. So that's where the sinogram is. Alright, then we'll do the same thing at 180 degrees. So again, we apply another detector at 180 degrees. Again, this here is the origin. Again, we look for a mark, for a signal, and we get the signal. Again, then the question becomes, is this minus 5 or positive 5? And by now we probably should know or probably have an idea that this should indeed be minus 5. So we put another mark at minus 5 at the projection angle of 180 degrees. So over here. And we will do the same thing and we'll make another detector. And we'll do the same thing right here. So this is at 270 degrees. And again, define the directions for positive and here for negative. And here's the center, 0. Alright, so where do we get a signal? Oh, should make the detector a bit longer. We get a signal right here. What is this distance? Is it plus or negative minus 5? It is, again, plus 5. So then we can now put a mark again at plus 5. Alright, and now let's have a look at 360 degrees. But yet, then it is probably no surprise that you end up at plus 5 again. So we can put another mark at 360 degrees because it's the same thing as the 0 projection angles. And here you have your sinogram. So now you can draw it, and you have your sinogram. Roughly like this. And here you have your, and here you have your sinogram roughly made in here. So this is your sinogram. This is how you should make it. All right, now here comes the bonus question, or the extra question, to be very careful. What is the radius at the projection angle of, let me see, if I say it correctly, at 135 degrees? What is then the radius at this projection angle? So we'll do this one as well, and try to understand or try to get an idea of what the radius should be at this projection angle. So what we'll do right now is we will delete all of this right here. Oh, wrong one. We will delete all of this right here. Try to think about that. All right, so we still have our point source. So do it like this. Should be fine. Oh wait, I need my point source. There it is. I think this should be fine for now. Alright, so let's have a look. We need to edit this one. Alright, so again, X and Y. So we have a point source right here. So 135 degrees, which is 45 degrees plus 90 degrees. So right here we have the angle. This is 45 degrees, and if you go another 90 degrees, you end up right here. So this is 135. So it's the marker somewhere in between here. We have 135 degrees. 135 degrees. Alright, so now we'll place the detector at that angle, at 135 degrees. So the detector will look like this. Bit longer. That's our detector. Again, this is the center. So in here we have the center 0. Alright, what we define again as negative and positive. Again, this was the positive one, and it was the negative side of the radius. Alright, so now I'm asking, what is the radius value of this projection right here? What number should it be? And again, we draw a parallel line right here. And what do you see? That this right here becomes our distance. This is our distance. This is our R, and it is negative. So this is the negative value of this distance right here. What is this distance right here? Which is basically the length of this line right here. And with the help of the Pythagorean theorem, you're able to figure it out. That this length is roughly 5 square root of 2. And that roughly equals to, let me type it in. That roughly equals to 7.07, which is the value here. So there's like, so this is the peak. This actually should be higher because it's the peak, which is minus 7.07, which is value right here. So this is like an additional projection you could make, but this is really, if you really understand this, the the radius, this length here, then you really understand the concept of projections to go from this coordinate system to a sinogram. You could use what I put up here, this equation right here. This is an equation that is given in the book. And but the thing is with this equation, that if you want to get this value of 7.07, that this equation assumes that this right here is the starting angle, is 0. Which means instead of putting the number of the angle 135, you need to put in the angle 45 degrees in this equation. If you do that, so 5 and then cos 45 degrees, 5 degrees plus 5 sine 45, you get, let me type that one in, you get indeed 5 square root of 2. But if you would type in 135, if you would type in 135 degrees, you would get a totally different value. That's why you have to be very careful on which values to use. But technically, I would just omit this one and just stick to these equations right here to be able to figure that out. Alright, so now let's have a look at the second part, part B. Let me erase all of this again. Alright, let's see. Or wait, let me show the 135 degree angle. I think that's also one interesting to show. So where was the point source again? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Point source. 1, 2, 3, 4, 5. Point source here. So then let's say if this is the starting angle, so this is 0, then we can use this equation right here. And now if we do that, then this is then we end up with, this is 90 degrees, this is 180 degrees, and then we end up in the middle. Let me see. With 90 plus 45 degrees, we end up right here. Is 135 degrees. So if we make the detector here, you probably might guess or probably have an idea of where the signal will end up and what the radius will be. Is if this is the center and then we get a signal along this line, then you can see that right here we get the radius, so the radius in this case equals to 0. But be careful, you cannot put it just in here because we assume that the initial angle was this one right here. So we will get 0 at, what angle is this? This is 180, 180 plus 45, 80 plus 45. Oh, let me just do that. Because 180, let me grab this one. Yes, so 180 45 equals 205. So somewhere around here, 2250, we will get a 0 mark, which is to roughly be around there. So this is how you should use projections. This is how you should use that equation. So be very careful when you use this equation. But just I would suggest to draw it like this, and try to understand and try to see what is actually happening. All right, so now let's go to question B. It's a little side quest. Let me erase all of this. All right, so the question asks, if a second point source is positioned at position minus 5,5, at what projection angle do the two coincide in the sinogram? So let us first draw in the points. Let me see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So at this point right here, you have 0.55, 5, 5, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then here you have the point minus. Oh, here you have the point minus 5,5. So you probably might get or see that if you have a projection along this line. Oh no, I don't like that. Let me end the line. If you have projection along this line, then you see that you will get that these point sources coincide. So now the question is, at what projection angle do the two coincide? So again, we assumed that this was the initial angle. So this is our 0 starting point. So this angle is 45 degrees. However, you're not there yet, because we did a projection from 0 to 360 degrees, which means that indeed right here, at this angle, the 2 point sources coincide, but also right here, the 2 point sources coincide. And this angle is 45 degrees plus 180 degrees, which equals 255 degrees. So at these two angles, the point source coincide. And that was it for now for this question, and I will see you in the next question. Thank you.